Hello, I'm here from Turtle and Tough to show you how to use our handheld field communicator to find a digital sensor's node address using the node scanning feature. As well as this, I will demonstrate how to change the node address of a connected sensor. To achieve everything in this video, you're going to need an HFC and a digital Turtle Tough sensor. Start off by connecting your HFC to your sensor. Once the two devices are connected, you can turn on the HFC by pressing the mode button. If 3 hyphens are displayed when you turn on your HFC, that means that your sensor is not being detected by the HFC. The most likely cause of this is that the HFC is attempting to read from an incorrect node address. To see what address your HFC is currently connected to, go to the node setting by pressing the mode button until the red LED is by the node text. The number currently displayed on the screen is the node address that your HFC is currently attempting to communicate with. If nothing is being read from this node address, then that indicates that your sensor is on a different address. If you know what node address your sensor occupies, you can change the node address that the HFC is reading by pressing the up or down arrow keys. As an example, I know that this sensor is currently on node 12, so I'm going to change up until I'm on node 12 and then press the mode button to save that information to the device. Now, let's go back to when our HFC was reading from the wrong node address and pretend that we don't know what node our sensor has. In this case, we will need to use the HFC's node scanning feature to automatically detect the correct node address of the sensor. To enter this mode, first change to the node setting, then press the view button. When you're in this mode, the red light next to node should be flashing and the number 0 should be displayed on the screen. This number represents the starting address of our node scanning operation. When scanning, our HFC will scan every address starting from this number one by one until it reaches 255. Choose your starting address by pressing the up and down arrow keys. If a starting value of 0 is selected in the node scanning mode, then pressing the mode button will exit out of the node scanning mode without starting a scan. I'm going to choose a starting address of 1 because I do not know what address our sensor has. Once your starting address is selected, pressing the mode button will begin scanning the addresses to find our sensor. Once our sensor is found, the type of sensor will flash on the screen, followed by the node that sensor is on. From here, our HFC will automatically change its selected node to match this number and your sensor will be connected. We can confirm that our sensor is connected by changing to the reading mode to ensure that a reading is being found, and then change to the sensor type mode to make sure that the correct sensor type is displayed. Now let's say that we want to change the node address of our sensor using the HFC. To change the node address of our sensor, we need to go into the baud rate setting on our HFC by pressing the mode button until the red light is next to baud rate. To enter the node address setting mode, we must hold the view button in the baud rate setting for 5 seconds. Doing so will cause both the node light and the sensor type light to flash. The number now displayed on the screen will be the current node address of the connected sensor. Press the up or down arrow keys to change this address. When you are happy with your selected address, press the mode button to save your changes to the sensor. To confirm that the address has been changed, navigate to the node setting on the HFC and ensure that the number displayed on the screen is the same as the address that you set in the last step. If this is the case, then you have successfully changed the node address of your sensor. Thank you for watching this video. For more comprehensive information on HFC function, we recommend that you refer to our product manual, which can be located on our website.